Welcome to this lecture on parameter parsing techniques. You would recall that parameters, also called as arguments, are a way to pass input onto a function. In this lecture, you will learn parameters can also be used to pass input as well as output. At the end of this video, you will be able to describe the two techniques used for parameters to functions, used for passing parameters to functions, differentiate between the two parameters called pass by value and pass by reference techniques, and also pass array elements into functions using the pass by reference technique. Techniques for passing parameters. There are two basic techniques to pass parameters. As we discussed earlier, pass by value and pass by reference. We will go into details of each one of these. Let's look at pass by value. In pass by value, the value of the actual argument is copied onto the formal argument. Now, if you recall what is an actual argument and what is a formal argument, when you make a function call, the arguments that you are passing are actual arguments. And the arguments that are defined in the function definition, the arguments that are declared as part of the function definition are called formal arguments. What happens in pass by value is changes in formal arguments or parameters do not alter the values of actual parameters. That is, the changes that you make in a function are not reflected back in the calling function. Let's take an example. Take a few seconds to see this code. You've got the function main. Main itself has two parameters. They are arguments themselves, which is argc and argv. We have declared a value, I value of type integer and assigned it to 10. You have a printf statement. Then we are calling the function fn increment, passing the parameter I value. Right? Function fn increment takes the one argument, takes the value of I value into itemp and increments the value of itemp. Now, before calling the function fn increment, the value of I value is 10. What we need to see here is what will be the value of I value after the function call fn increment. To go into details, let's look at how memories are assigned and how the control flows. Now, the moment we have set I value equal to 10, you've got in the location address, let's say 1000, I is defined, 2 to 4 bytes of memory based on how many bytes an integer requires is allocated, and 10 is assigned into that memory. I value equal to 10. If you print the value here, I value is equal to 10. Now, we are calling the function fn increment with the parameter I value. Value of I value right now is 10. So, control goes to the function, which is fn increment. When the control goes to the function fn increment, you have another variable itemp. That is, a new variable itemp gets defined with similar, let's say 4 bytes for an integer, so 4 bytes of memory, in a separate memory address, which is 5000. And the value of I value gets copied to itemp, right? That is called pass by value. That is, the value is getting copied from one address location to another address location. The address location defined for the local variable I value in main to the address location defined by the variable itemp in the function fn increment. So now we have this value local to fn increment, the variable itemp. Now what is the next statement? We are saying itemp plus plus, that is incrementing the value. Itemp plus plus refers to itemp equal to itemp plus 1. So what is the value of itemp here? The one which is copied from I value, which is 10. So if you increment, the value becomes 11. Now the control goes back to the calling function, goes back to the main. The moment the control goes back to main, the variables defined which are local to fn increment are no longer there. The memory space gets released. Now when I go back to the main function, what is the value of I value? I value is at a different memory location and the value remains the same. There is no change in the value. So the output would be 10. So what have we learned here? We have passed a parameter by value. When you say pass by value, the value gets copied from the address location of the calling function to the address location of the calling function. Two address locations being different. The value gets copied. The processing happens on the new address location, which is local to the called function. After the control goes back from the called function to the calling function, the memory space gets released. So there is no change in the value. So if you understand how memory locations are allocated, understanding pass by value is very simple, right? Now, let's look at the other technique, which is pass by reference. In pass by reference, we are not passing the value, we are passing the address of the variable, so that in the called function, you can refer to the variable which is defined in the called function. Let's look at that in detail with an example. The other point to be noticed, changes in the formal parameter alters the values of actual parameter. Actual parameter in the called function gets altered because the formal parameter now refer to an address. Now let's look at this example, the similar example which we covered in pass by value, and see how pass by reference will work. What is the difference between the last example and this example? You see I value is being defined, declared, and initialize the value 10. Then you're printing the value of I value, but you're calling the function fn increment not with the value of I value, but with the address of I value. That is the key difference. And when you're passing that to fn increment, what you have defined there is a pointer variable. Remember, itemp is of data type int star, right? So to understand this more in detail, let's draw some memory maps and try to see how pass by reference works and how we are able to change, how we are able to pass arguments using pass by reference. Now, I value equal to 10 defines a memory location. Let's say address is 1000. You see initialized to 10. I print the value of I value. What gets printed is 10. The control now goes to fn increment ampersand I value. So what I'm passing, the previous case, I was passing the value 10, but here I'm passing the address of 10, which is 1000. That gets copied into itemp, which is local to the function fn increment, right? So what gets copied into itemp is not the value 10, but the address of I value, which is 1000. So itemp is local to fn increment. So let's say that is defined and declared at a memory location starting 5000. What gets copied is 1000. Now, see, the value of I value is still 10. We've not made any change. But now we are referring to the address in the called function, which is fn increment. With star temp plus plus, what we're trying to achieve is star temp is equal to star temp plus 1. So when you say star, star is a content operator. Ampersand is the address operator. Star is the content operator. So star itemp would refer to the value inside the item, inside the memory location 1000, which is 10. So from the called function, we are able to now refer to a memory space in the calling function. The moment I say I star temp plus plus, the value at 1000 from 10 becomes 11, right? The control goes back to the main function. What happens now? The variables which are local in the called function, those variables are no longer available. The memory gets released. But what we have accomplished is, because we have passed the address, we have actually changed the value of I value. If you print that value of I value now, I value becomes 11. So if to understand, to get the concept in more clarity, pass reference is again passed by value. There's no big difference. The concept still remains the same. But what you're passing as a value is the difference. In the previous case, when you just say pass by value, you're just passing a value of an integer or a float or a character variable. But in pass by address, you're actually passing the address. Again, it's a pass by value, but passing what kind of value? The address. That becomes pass by reference. It's a very important technique, very useful to make sure that you pass multiple inputs and get multiple outputs. By just using pass by value, I can have multiple inputs onto a function. But through return, I can only return one value. But using pass by reference, I can pass pointers as multiple arguments, and in my called function, I can make some changes. That means I'm having multiple inputs coming in, and I can make those changes to each of the arguments. You can have multiple outputs. That's a very important concept of pass by reference. Right. Now, a couple of key differences between pass by value and pass by reference. Pass by value consumes more memory space because every time you're passing value and you're defining local variables, so memory gets assigned. It takes more time for execution because new variables are getting assigned. Pass by reference consumes less memory because what you're passing is just the address, and in pass by value you might have variables of different data types. Each one of them might have different addresses, but in pass by reference you're only going to pass the address. Now address always would consume, let's say, 4 bytes. So that way the space is consumed and it takes less time for execution because your code becomes smaller. So given a chance, I would always go for pass by reference and optimize my code.